Okay. I think it's recording now. Okay, I'm sorry. I would. Today I'm working in a Starbucks, so it's really loud their music. So now, but now right now I'm outside. I'm gonna do a really quick review, so I'm not gonna space too times before I finish this video. First I want to show you this. I know some students are kind of nervous about the final. This is not the I know this is not the only class you're taking. You probably have a lot of course load. I just want to say this is like a really cute Disney thing. It's like just it's all gonna be alright. Okay, just keep going. It's all gonna be alright, and you are all gonna be fine. Okay, and now let's do non-parametrics. Um, this non-parametrics we did cover some last Monday, right? Robert Crafty did such a great job, and so he covered everything in the one sample non-parametrics. We professor it's gonna cover the two sample parametrics next Monday, like tomorrow. But here I'm just gonna go through it just in case you want to know what is happening before next Wednesday the exam. So I'm still gonna do a recitation, like a brief review of everything on Monday, like tomorrow at the recitation time. I'm just gonna go through what I'm doing here in the exams review session, and I will hold a like 7 hour from 9 a.m. to 4 p.m. I'm gonna hold a really long office hour on Wednesday before exam, so it's all gonna be alright. Just take time to study, and if when you have a problem, just come and see me. I'll just be in the comments, okay? mm, yeah, I think that's it. And let's get started. This has a lot of pages, as you will see, but I taught this class I think in April. Um, so this is gonna be the complete notes of what is non-parametric. We're gonna go really quick for the one sample one, and then we are gonna have more detail on the two samples one. Okay, awesome. Okay, so we all remember this table, right? So we have already go through everything here, and now um, this is the non-parametric ones. And so this is one sample theta, this is two sample theta. So Dr. Crafty covered everything here, and then we are gonna do here, okay? But before that, and then this one, of course, we're gonna still gonna walk through briefly about this, okay? So this is non-parametric, this is parametric. That's why this one sample theta is gonna be linked back to this one sample t-test, and this two sample t-test is gonna link back to this two sample t-test. Okay, awesome. And now, so we always talking about assumptions, right? It's all the time. It's like, oh, the assumptions need to be normal, and sample size need to be big enough. It's 30, like 50, and sometimes like the small one's gonna be greater than 5, greater than 10. So what if we cannot meet the assumptions? That's no problem. That's what this class is for. Even though we don't have all the conditions met, we still have the non-parametric ones. So it's gonna be no parameters, no distribution, like no parameter, no problem, no distribution, no problem. It's not normal, no problem. It's not binomial, no problem. That's why it's like no problem, non-parametric. Okay, so non-parametric test, let's say what's included in it. For one sample one, there's sign test and sign rank test, and then there's like weak, medium, and strong. So this one is parametric already. For two sample ones, this is median test, and some rank test, and then two sample t-test. For more than two, if there are more than two samples, it's gonna be KW test, and these tests are based on signs, ranks, or medium. So it's gonna be like weaker because you have less information, right? Okay, for one sample and two paired sample, that's what we were talking about in last Monday. Dr. Crafty has explained all this concept really clear. So let's go through this really quick. So that's where we're gonna use the sign test. So this is like all the number, and then this is like before, this is after. What we're gonna do is we're gonna calculate the difference, and then we're gonna say what's the sign of the difference. We'll throw the 0 away, and then we're just gonna say then it all turns out to be a binomial distribution, right? And then for this binomial distribution, we can do the test it that way. We want to calculate what's the probability of observing something or more extreme, right? So here is a thing. And so this is the stata command. You're going to use like sign, because the sign test, right? So you're going to use sign test like this one equal to this one, and then you choose like it's one-sided or two-sided. If it's one-sided, which like this greater sign or smaller sign, right? Now here we're using the two-sided one, so this is like the 0.1797. Okay, and so this is the oh, sorry, I'm outside. I guess it's not connected. So this is the command you're gonna use in Stata, like not command. Sorry, this is the click thing you can use if you can't remember the command. This is like a click thing, yeah. And now, next step, we're just gonna do the sign rank test. So this is the sign. Let's here. Okay, let's use red. Okay, sign test is only based. What's wrong with this? Okay, sorry. I'm gonna close this. Okay, so the sign test is on signs. It loses so much information, so it does not take on on the size of the difference, right? So we want to not only the sign, we want the difference, how much different it is. So we're going to introduce another like stronger than sign test. That's going to be sign rank test, because this guy invented, so we call it Wilson sign rank test. So this one is also covered by Dr. Crafty. It's so we're just going to calculate the difference, and we're going to rank the absolute difference. So then we combine this sign.
You smoke?
Okay, thank you. So this is gonna be the. We're just gonna. It's okay. We're just gonna. Let's start over. So here is the before, and this is the after. This is the difference, right? So this is the absolute rank of absolute difference. Now we combine this absolute difference, this rank, with the sign, with the sign. So it's going to be sign rank, right? That's where the name comes from, sign rank. So now sign is only sign, and rank, this like slightly stronger one, is going to be sign rank. We gave the sign, combine the sign with rank, and this is what we got. And then if the drug has no effect, we would expect it's going to be half and half. You do the same thing with the other one. Then this is the command we're going to use, and this is the p-value. So that's where you're gonna find everything, right? It's like this is the right part. And this is the click where you can do it in Stata. And then now for two independent samples here, now we're changing. Now I'm gonna let's take a pause here. So this is page 19. Let's come back here. So what's actually we were talking about sign rank, and sign rank, right? So that's all one sample. Now we're going to two samples now. What we're gonna do is median test and the rank sum test, okay? For mainly this one, mainly this rank sum test. Okay, before we start, I want to say something like, this one is really weak, this one's really strong, but this one is, let's draw, like if this is the sign test and this is the one sample t-test, this is one sample t-test, you would imagine like sign rank is here, right? No, sign rank is probably here, so it is robust enough, okay? Sign rank is like here. So sometimes doing, like if you don't have all the conditions met, the sign rank test is good enough, okay? So it's the same thing here. So if this is the medium one, And this is the 2-sample t-test one. I would say the rank sum is here. So this, like, the sign rank SR and the rank sum RS is 2 tests that's been underestimated, I would say. Okay, now we're just gonna go to 2-sample now. Okay, so let's go to page 19. Awesome. So the non-parametric test for 2 independent sample is Wilson sum test. We're not gonna do the median one because it's really weak, So also known as MWU test. Okay, let's just highlight them. The parametric test to compare this is the t-test. Well, of course, it's a t-test, but sometimes it's smaller than 30, sometimes not normal. So what do we do, right? So we're gonna use non-parametric ones to compare things. Run some tests. So an investigator wants to compare 2 competing treatments for adults onset diabetes and 8 subjects. There are only 8. It's not like in each group it's not greater than 10. Like 8 subjects are randomly assigned to 2 treatments. So for each, that's so small, right? They follow a prescribed treatment regimen for 6 weeks and then rate their current health status on a scale 0 to 20. The question of interest is the self-rated health difference for the patient between the 2 treatment groups. So here are the numbers. Treatment 1 and treatment 2, here are the numbers. So here we have small samples, so small, and the variable of interest is ordinal. So a non-parametric test is perfect. To perform this Wilson rank sum, see this guy, he invented the sign rank, right? He invented the sign rank. So this guy, just remember him this way. He invented the sign rank. So he invented the SR test and he invented the RS test. So he invented those 2. Like, I think it's really like neat to know this. So we first pull the data and rank the score. We pull them together. Okay. So the rank of this score will be, see, we make them together. This will be 1, and this will be 2. This is 3, 4, 5, 6, 7, 8. So it's 1, 2, 5, 8, right? So yeah, that's what's happening. So we are gonna rank all of them here, and then we sum them. So that's why it's called rank sum. That's really neat, right? So this sum is 16. This sum is 20. If there was no difference between the treatments, we would expect this low ranks and high ranks are there will be, like, you see some low ranks and some high ranks in each group. If there is a difference, we would expect to see like clustering of high ranks in one and the clustering of low ranks in another one. And now this is the command you're going to use. And so here is where you find the p-value. We are always looking for the p-value, right? And this is a rank sum test. And this is the command where you do the click. Okay, awesome. Now, actually, let's go back here again. So this is page 25. So we're just covering the rank sum, this one. Okay, so Wilson discovered sign rank and rank sum, SR and RS. Now we're gonna do, do you remember we're doing like 1 sample, 2 sample for the population mean? We have t-test, pair t-test, and then like independent or independent, and then we have more than 2. What do we do? What we did is ANOVA, right? Is there an ANOVA for non-parametric ones? Yes, this is the non-parametric ANOVA. Here, 25, page 25. We're almost finished. Here, so if there are k independent samples, what are we gonna do? A non-parametric ANOVA is this KW test. So we're comparing k independent samples. In ANOVA, we're comparing k sample means based off the actual data. For KW, we're comparing means, but the means of the ranked data, not the actual scores. So SK is similar in theory to the Wilson rank sum test, except we do not ignore zeros. Do you remember we're kicking off zeros because if it's equal, it should be like 50-50 when we kick out the zero, right? But here we do not kick out the zeros. Awesome. So now here's the question. Now we wish to compare full treatment of seasonal allergies. So a total of 20 patients were randomly assigned to 4 treatments. So it's 5 people in each group. I know it's greater than 5 now, but still it's really, really small. And each person followed the prescribed treatment for 4 weeks and then were assessed for symptoms. Each were assigned a sample score. The range of the score is 0 is no symptoms and to 3 like all symptoms. We want to know, is there a difference among the treatment with respect to symptom scores? Okay, so this is treatment 1, this is treatment 2, treatment 3, and treatment 4. Let's rank them. So here, do you see like there are 1, 2, 3, 4, 4 zeros. How do you rank that? Yeah, how do you rank that, right? It should be, so the 0 should be 1, 2, so there should be 1, 2, sorry, my finger is frozen, 2 and 3, 4, right? And so they are kind of tied. So how do you do the tie? You average them together. So all of them get 2.5. And then the same thing happened to 1 and others. So this is how you rank them. But I mean, it doesn't really matter you understand this or not. You know the command, so you just do the command and find the p-value. This is just the mathematic how you calculate by hand. But come on, at this age, who calculate by hand, right? It's probably biostatistics students. You don't need to do that. So we will calculate it by hand, but you can just use a command. So here are you rank them. So this is where the rank came from. There is some, and then that's the would expect all of this should be like kind of equal, but it's okay. You just do this. This is the command you're gonna use, and this is the p-value you're gonna find. Chi-square. No, this is the test statistics. This is the p-value you're gonna find. So you reject it, and this is a click. Okay, so now we were talking about correlation coefficient, right? That's in linear regression. So how about non-parametric correlation coefficient? What is that? It is the Spearman rank correlation. So it's just like, we have a set of non-parametric stuff just to correlate with the parametric stuff. So this is just something I guess it's kind of interesting to know, or it's really fun to know. There is a correlation for non-parametric ones. So rather than computing the correlation of the raw data, you rank the data first, then you compute the correlation of ranks. So the formula is this one, and this is the stata command you're gonna use. And so this is sig. This should be the x. This x should be the y, and then this row is this number. That's what we're saying. The test is this one. Are independent or not? You remember that's a line, right? It's a linear, right? So this is independent or not. So this is the value if it is not independent or not. So we would say it's not. It is not independent, so it's kind of have a relationship. So this is the click for how to do it in Stata. Awesome. This is actually the end. Awesome. So good luck for final week and best wishes, everything. Bye bye.